finish section 9.5 today, and we have 2 more questions actually to do, and each of them have a couple slides. And we've actually talked about a standard 52 card deck once before. We talked about the probability of getting red, and the probability of getting kings, and the probability of getting, jack of hearts and things like that. We talked about different probabilities within a deck of cards. I want to talk about the deck of cards, though, in terms of combinations and permutations. So this section one you'll remember. So what's the difference, first of all, between a combination and a permutation? Yeah, just a little bit. Order matters with a permutation, right? It matters whether I put my underwear on first or my pants on first. That matters. Order matters. It may not matter whether I put my shirt on or my pants on first, though. That probably wouldn't. So, some things order matters for, and some things it doesn't. Okay? It matters. The order matters whether or not you have a oldest child who's a boy or an oldest child who's a girl. Right? It changes the family structure. It's a different ordering. Order would matter. It would be different. All right. So on this one, we've got a 5-card hand dealt to you. First question: does order matter? We're not replacing any cards. We are a dealer, and I give you 5 cards. No, it doesn't matter. So, Madison, why do you say no?
Because it's restoring them, not replacing cards.
Even if you were looking at the cards.
Because I'm not really at
Okay, so let's imagine, what's a card game you guys play? Not with 52 cards, which is a card game. Card game you play before. Everybody plays some kind of card game before. You play Uno? Or Crazy 8 or Old Maid or all the different games you play when you're a little kid. Usually, Go Fish, another one, War doesn't count, that's not a very good example. Usually what you do when you get a hand of cards that you're playing, the first thing I do is I reorganize them. Put in the game. Sometimes it means you put them in number order. Sometimes it means you put them with suits in a different order. Or by colors, right? If you're doing like Uno or something like that. So, yeah, the first thing you do is you reorder them because the order that they were given into you doesn't affect how you play them or anything like that, right? It doesn't. So this does not have the property that order matters, which means this problem would be which one? A combination. So this is a combination. Because the order does not matter. Okay, so that's an important feature first. All right, so the question is, how many different 5-card hands could I have? So we sort of have this image in our mind that it shouldn't be that many because there's only 52 cards and I get 5 of them and it shouldn't be that big. But let's take a look at that, okay? So combinations means taking the number of items I have to pick from, which is 52, and I do a combination with however many I'm choosing, which is 5. So I have 52 cards and I choose 5 of them. So the formula for this says I'm going to do 52 factorial on top, and then, that doesn't look good, pretend. And then I have 5 factorial on bottom, and I have 52 minus 5 with a factorial also on bottom. Everybody with me so far? Great. What's 52 minus 5? Thank you, Madison. It is 47. Now, some of your calculators do wonderful cool things with these, and so we talked a little bit last time about what I want to see. So far, everything I've written is something that I would expect to see, either that first equation or the second one, but no, I don't care which one of those two you write. But the next part I want to see as well. I want to see this 52 written out until you get down to 47. Because remember from last time that once you actually get, I know I'm not done with my fractions, once I get down to the 47 factorials that are identical on top and bottom, they cancel out. So you can't cancel out factors with factorials like this, but in that sense, but you can actually cancel out entire factorials that match. So these are going to cancel out. I also have a 5 factorial here. I'm going to go ahead and write down 5 times 4 times 3 3 value in the denominator will simplify with the value in the numerator. What will 5 simplify with? You could. 5 times, what was that? 5 times 2 is 10, right? And 50 divides by 10, how many times? 5, so 5 left. Good. What about that 4, or the 4 and the 3, or the 3? What would you do next? What would you like to do next? All right, so 4 times 3 is 12. And 12 divides 48 evenly into 4 pieces. And then you can grab a calculator, and you can let your calculator multiply. 52 times 51 times 5 times 49 times 4. Step that I just wrote out, you don't have to write that. But that's what I want you to do in your calculator is to multiply those. And once you do, let me know what you get. Yeah, so 2,598,960. You know what, Jude, that sounds like a lot of different words, doesn't it? Yes, thank you, Hannah, it does. All right, so let's take a look then at what happens when I take my deck of cards and I want a certain kind of possibility to happen instead. So instead of just wanting to know how many random, hands of cards that could be dealt, I want to know how many cards that could be dealt that contain all diamonds. So again, order doesn't matter, right? But I do want them to be all diamonds. So how many diamonds do I have to select from? There's only 13 of those. And how many am I going to select? 5. So I've got 13 factorial over what? 5. Right. The 2 numbers on bottom have to add them on top. So 5 and 8 do that. And it's 5 because I've got C5 at the end here. So then I'm going to write down my 13 until I get to 8 factorial. So 13, 12, 11, 10, 9, and 8 factorial. 8 factorial, the denominator matches. And then a 5, 4, 3, 2, and 1 if you like it in the denominator for 5 factorial. Tell me what I can cancel.
5 and 2 is 10.
All right, so 5 times 2 is 10.
4 and 3.
4 times 3 is 12. And 8 factorial, which you maybe already did. I hadn't. But yeah, the 8 factorial. So what I'm left with is 13 times 11 times 9. 1287. And you might have thought coming into this problem, if I looked at this without doing part A, 1287 units are all diamonds. That means they just happening pretty frequently. That's 1287 compared to the 2 million number that Audrey told us before, right? Significantly less. And if you've ever watched, okay, so by the way, a 5-card hand with colors, all the colors matching it is called flush. So what we're describing in this particular problem is called a flush diamond flush. We could also be talking about a heart flush or a club flush or something like that. It's whatever suited is called flush. It's got all the same cards, colors. It's called a royal flush. I think if they're the top ones, that they have the, is that right? It's not. I think that's what they call them when they have the ace, king, queen, jack, and 10 would be the royal flush. We're not doing that particular one, but diamond flush. So probability, this is why this is coming up in this section. Probability compares the number of ways of getting one event compared to the total number of ways of any events like this occurring. So if I want to know the probability that I end up getting a diamond flush when I'm dealt 5-card hand of cards, what would I do? The 2 answers are what I do with those 2 answers. Yeah, so let me write out what I'm doing in words and then let me do the numbers. So I would want to know the number of ways to get all diamonds divided by the number of hands, or, yeah, number of different hands of cards, we'll say that. I didn't write 5 card hands here, but that is what we're working with. So we'll always have that feature of them. So that was the 1287 divided by the 2,598,960 from part A. You're going to grab your calculator and you're going to divide. And when you do this division, it's going to be an awfully small number. You want to leave it in decimal form. And let's just write down all the zeros until we get to one number that's non-zero in decimal expansion and go with that. Your calculators are doing something a bit interesting. Say that at the end. What did your calculators say? All right, so let me write down what you said. Say it louder for me, Madison.
4.95 e to the negative 4.
Do you remember what e to the negative 4 means? Your calculator does that?
With the decimal.
Do you know what it's called? That's scientific notation. This e negative 4, what this really means is 4.95 times 10 to the negative 4. And Hannah is right, it means move the decimal 4 to the left. So this is actually 0.000495. And if we just round it to one value of non-zero-ness, if you will, whatever, I would have 0005. Now, if you multiply this by 100, you turn that into a percentage. That means there is a 0.05% chance of getting this game of cards. So if you ever do, in fact, watch the poker channel, which my husband was addicted to, not addicted to poker, but he enjoyed watching the poker channel. So for a while in our house, this played a lot on television, and there was this big deal. I mean, it just seemed like there was kind of a wave of being more popular. And so they would tell you when they were playing, they were playing Texas Hold'em, when they looked at the cards, how likely it was that each player would win. They were using probabilities, permutations and combinations to do this, particular combinations in these different hands of cards. So they were doing mathematics actually to figure out how likely they would have it. It looked an awful lot like this. But all you saw at the end was that this person had, a 5% chance or a 2% chance or a 3% chance or whatever, and they get this like that. Okay. All right, we've got one more problem, and it's not about cards. We have a committee. It's a committee of 3 people, and the 3 people are selected at random from 7 seniors, 5 juniors, and 3 sophomores. Question number 1 says, what is the probability that the committee consists of all seniors? So how are we going to find that? We're going to find a couple combinations, aren't we? So before I actually find the combinations, can you describe the kind of combinations I need to find? The number of committees, I think I left an in out of committees. Yeah, if I did. Pretend. There's 2 ends right there. Number of committees of all seniors. And then the other one you said, Audrey, was the number of something like maybe total committees, or the total committees possible. And each of those independently, just like on my last problem, that would have been the part A and the part B on the problem, have to be found using combinations. So let's do the committee of all seniors. How many seniors are there? 7. And how many seniors do I need? Or how many people are on my committee, I should say? 3. Now, how many people total do I have? There are 15 people. And again, how many people are on this committee? 3. So what I actually need to find is 7C3, 15C3, and then divide them. Okay? So let's sort of put a pause in the process right here and find each of these down here. Okay? So how do I find 7C3?
7 factorial divided by 7 factorial minus, where is it?
Okay, by 3. So how do I do 3?
3
and then-
factorial, then 7 minus 3.
Yes, 7 minus 3, which is 4. Yeah. Okay, so I have 7 factorial. And I'm going to write out 7, 6, 5, and 4. Stop at 4 factorial to compare. And then the 3 factorial is 3, 2, 1. What simplifies? 4 factorials cancel. What else? 3, 2 is 6. I'm left with 7 times 5, which is 35. So there are 35 different committees that I could make consisting of 3 people when I select from among the 7 seniors. Now I have to do it with the 15, the total group. Okay, so what is this combination going to look like written out? Lovely. Okie dokie then. So we've got 15 factorial that I'm going to write down that I get to 12. 15, 14, 13, 12 factorial. 3 is 3 times 2 times 1 times, and then I have another 12 factorial. What cancels? Uh-huh. Sure. 3 goes into 15 how many times? And 2 goes into 14 how many times? 7, right? What is 5 times 7 times 13? Now you could do this one of 2 ways. Actually, in essence, what I have up here then is 35 divided by 455. And let's go ahead and put it into a decimal expression for that. It seems most reasonable, and then we'll do the fraction expression in a second. But what would the decimal expression be? Okay. So that's like 7% chance, right? If I multiply by 100, I turn it into a percentage, we can say 7% chance there. If you want to work in fractions, you could actually work in the fractions before I multiplied. This would be 7 times 5. And if you look at the bottom, it's 5, 13, 7, and 13. And if you take a look, it's actually 113 if you want to do the fraction form. You're happy to do that too, or you can factor it back out again. But either way written is fine. You can get it in decimal form or in factor or in fraction form. All good? All right, now we have one other question about my committee. This question says, what is the probability the committee has no seniors? Okay, it's all or nothing. Those were 2 questions. One thing you have to be careful of here is that this is not the 1 minus the first probability. We encountered a formula about that last time. What committee would be created that doesn't classify either of these categories? Yes, you're answering my question already. You're right, Audrey. I'm going to get that to you in just a second, but I want to ask one question before you do that. You're right. This committee that I'm describing would be a committee of only juniors and sophomores. This is not the only way this one versus Part A to make a committee. What committee is not represented in these 2 questions? That's the probability that is describing. Probability of having juniors and sophomores only on the committee.
Well, actually, and just like, if there were only juniors on the committee, say the possibility of that.
But that would be including this possibility. Having a committee of only juniors or a committee of only sophomores would be included in the probability I'm finding right here. But there is a possibility that I have not included in either of these categories. Yeah, I mean, that's kind of the idea, right? A mean, I don't have to have no seniors or all seniors. Couldn't I also have like 1 or 2 seniors on the committee? Sure, I could, and that's not represented in either part of this problem, right? So you want to be really careful that you understand what the question is specifically asking and don't infer something beyond what it asks. Like for instance, if I wanted the question where you could take 1 minus the first probability that is the complement of this, my question would have to read something like this. What is the probability that the committee is not all seniors? Okay, well, that doesn't mean no seniors. It just means that there's somebody on the committee who's not one. If I had that question, I could just take 1 minus the previous probability, and 1 minus that 0.07, or 1 minus the 113, and I would be able to find that other probability. But this one's not asking that. So, Audrey, you told me what I wanted to do. What do I want to actually find on this one?
I can give like the junior sophomore, so it would be like 8.
So I need the committee of juniors and sophomores, number of committees of juniors and sophomores divided by the total number of possible committees. And you were telling me what's going to go on top, so go ahead and do that for me again, Audrey.
Oh,
8C3, and then on the bottom it's the same, was it 15? Four, huh? It was 15, right?
oh, yeah.
15C3 that I had before, which, yeah, was 455. Don't reinvent the wheel. We don't need to find 15C3 again. We already did that one. But we didn't find 8C3 yet, so let's do that. Okay, so how do I find 8C3? 8 factorial over. Great. And I'm going to write the 8 out until I get down to 5. So 8, 7, 6, 5 factorial. And then I have 3 times 2 times 1, which gives me, yeah, the 3 and the 2 cancels with the 6. 8 times 7 is 56. So it's slightly more likely, right? 56 is compared to 35 on that numerator of getting the committee to have juniors and sophomores only and no seniors in versus then getting all seniors. And this is a decimal, what would it be? I think it's smaller than that.
I
Right?
got 0.12.
Okay. 0.12, and you'll go with whatever the decimals they tell you. No problem with the 2 decimals, it's fine. They'll tell you to do 4 decimals with that. At least 2 decimals on any kind of probability is kind of a minimum from my standpoint. So if it only asks you for, you know, or if it asks you for more, then do more, but otherwise at least do 2 decimals for it. You guys feel like that math? Okay, good. Any questions on this one?
Where did you get the 8? And the 3?
On the other problem. There were 5 juniors
And 3 sophomores.
and 3 sophomores, so there's 8 of
So
them.
you added it and then just did 3 sophomores?
Well, not 3 sophomores, I did 3 because I'm selecting a committee of 3 people.
Oh, okay.
Same committee I wanted before, but just I
Okay.
want a committee that only has sophomores and juniors as opposed to seniors.
Okay.
Any other questions?